Hello, we will look at the binomial distribution and the hypergeometric distribution in this video, and you should have looked at the lecture notes already on those two topics. I expect you to be familiar with the characteristics of a binomial versus a hypergeometric, so I'm not going to get into all that. We'll just get right to the some of the calculations that are involved in the binomial distribution here first, and then we'll get to the hypergeometric. So let's say we have this situation where we have we've got a store here, and we're interested in what the next customers will do here in terms of using a credit card or not using a credit card. So there's the binomial situation. They'll either use a credit card or not use a credit card. Over time, it has been established that 75% of the customers for this store use a credit card. So we can use that as our probability of success. I use the letter pi to represent that. I know the book uses p, so just have to kind of deal with that. I prefer using a Greek letter to represent what I consider a parameter here. So you have probability of success. We have the number of trials, 10 customers. So what will happen with the next 10 customers for this shop, and we can construct a probability distribution on those 10 customers. What's the probability that 0 of the 10 will use credit cards? What's the probability 6 of the 10 will use credit cards? What's the probability that less than 7 will use credit cards? So things like that. Well, one way is it's not the hardest way, but it's the long way compared to a couple other methods that we'll talk about later, and that is to use the binomial formula. And I do want you to be familiar with this. Basically, what you need to do is figure out how many different ways this x could happen. Okay, well, that's the combination rule. And so that's just taking n factorial times x factorial, so 0 factorial, n factorial is 10 here, divided by 0 factorial times 10 minus 0 factorial. So that can happen one way. So then how many ways can it happen where just one person uses a credit card? Well, that can happen 10 different ways using the combination rule, and we did that under the counting rules lecture notes and videos, so I expect you to be familiar with using that formula. Well, then you need probability. So now we have, so we have the number of ways each can occur, but now we need probabilities to go along with that. And so what's the probability that what is a joint probability, basically? What's the end probability of multiplying out all the either probability of success or probability of failure for the particular path that represents either 0, 1, 2, or 3. Okay, and obviously there's multiple paths for 1 through 9, but they all would end up with the same joint probability. So you would multiply, in the case for 1 here, you would multiply 0.75 times 0.25 times 0.25 times 0.25 up to the 10th person, and then we would find those probabilities then by using this formula here. So the probability of success to the x power times the probability of failure to the n minus x power. And so that's what we've done here. Okay, so it's a little hard to see it in this manner, so it's probably better to kind of look at it in this formula, and again, it's in your notes. So we do that for each of these x's here, and these are each of the joint probabilities. So then we basically have to add up for how many times these occur. Well, instead of adding them up, we're just going to multiply by the number of times it occurs. So 210 times 0.000077 will give us the probability of 4 people using a credit card out of those 10. So I've already done that. This is just these two numbers multiplied together. So let me copy that down. Okay, and so now I have a probability distribution, and I can make a cumulative probability distribution by adding up all these probabilities. Okay, and so using the binomial formula, we can come up with a probability distribution if we know the probability of success and we know the number of trials. Well, from that probability distribution here, we can find the expected value. Now, I've already got it done here for you because we've already gone through how to do this, so I don't want to take up time for that. But you can see that if we take x times the probability of x for each of these values and sum them up, you get 7.5. So that's our mean. That's our average number of individuals. You know, out of 10, out of a group of 10, that would be the average that would use a credit card. Now the expected number, so if you just had one group of 10, you would expect probably 8, because that's got the highest probability. That would be our mode there. But over many groups of 10, the average would be 7.5, if this is true here. Okay, now for the variance, I'm doing the shortcut method. We find the expected value of x squared, and we subtract the expected value of x, that value squared. So we get 1.875. Now we did all this here, but it turns out that you don't have to. You can just take n times pi, and you got yourself the mean, expected value of x. And for the variance, you got n times pi times 1 minus pi. And now you have yourself a variance, 1.875. So we didn't have to go through all this. That's for the binomial. So then the square root of the variance is obviously the standard deviation. So pretty quick way of getting the some basic descriptive information. Now, and even an easier way than using the binomial formula. The hardest way would be constructing a probability tree for something like this with 10 different customers, and because you'd have over 1,000 joint probabilities that you would end up with at the end of your tree. So that would be crazy to try to do. So compared to that, this method is pretty nice. But even quicker and easier than that is the Excel function, the binom.dist, where you just identify the x value, the number of successes that you're interested in, the number of trials, so 10, and then the probability of a success, 0.75, and then if you want just a probability distribution, you put in 0 or false here. If you want the cumulative probability distribution, you put in 1 or true. And so then you end up with exactly what we got here. And then one more thing that the Excel binom command will give you. If you put INV instead of dist, you can kind of go the other way. You can say, okay, well, let's find x such that the probability of the number of customers using a credit card is less than or equal to that x is equal to, let's just say, let's use a number here, 0.0035. Okay, so if I use this command here, this INV, binom INV, so I've got the number of trials, I've got the probability of success, and I've got my cumulative probability here. 0.0035, then since I'm using an exact number here, it should come out exactly at 3. Okay? We won't really do much with this, but I just wanted to let you know it was there. And now we'll look at the hypergeometric distribution. Now we have a situation where probability of success is not a constant. In the last example, the probability of success remained at 0.75. Here, we don't have a specific probability of success because it's going to change as we pick a entity out of the population. And so we use something called the hypergeometric distribution. We're going to use the combination rule, but in a very different way than we did for the binomial. So let's look at this problem here. We got 30% of 20 students that are on the wait list. They're seniors, so that means there's 6 seniors out of the 20 total that's on the wait list. And then we're going to pick 5 from that total of 20 at random to put in the class. Well, what is the probability that all 5 will be seniors? Okay. Well, obviously as we keep picking either a senior or a non-senior, the probability of success and failure is going to change. So that's why we can't use the binomial distribution. So we use the hypergeometric, where we need the number of ways in which the 5 seniors will be chosen out of the 6 seniors that exist on the wait list. Okay, and then we need the number of combinations in which no non-seniors, 0 non-seniors, will be chosen out of the 14 total non-seniors. So those are combinations that we'll have to calculate, and we're going to multiply those together and then divide by the total number of possible combinations that could exist, whether they're seniors or non-seniors. And so that involves taking 5 students out of a total of 20. How many different combinations are there that could occur for this particular example? So what we need then is the total number. We need the number of seniors, okay, that are in that total, or among that total. And then we need to start thinking about the sample. So those are really the population. And then we need the sample information. So we're going to pick 5 students, and I want to know what's the likelihood of getting 5 seniors then. All 5 of those students that are picked are seniors. So you can see there are 6 possible ways in which the 5 seniors can be chosen out of 6. So there are 6 seniors altogether. There's 6 different ways that 5 can be chosen. All right. Well, there's only one way in which no non-seniors can be chosen, out of the 14 remaining. Okay. And then there's a total in which of over 15,000, 15,504, in which 5 students, just 5 students of the 20, are chosen. So it could be the first 5, it could be the last 5, it could be anything in between. There's over 15,500 that ways that could happen. So we take the product of these two numbers and divide by the total combination, and you get 0.0004. Okay, and you can see there's a Excel function here, hypgeom.dist, in which if you identify the x and then n, and then the x sub s, the population number of successes, and the total population. If you put 0, you get the probability. If you put 1, you get the cumulative probability. Okay. So then if you use, you try to answer this, what is the probability 2 will be seniors? That's maybe a little more realistic, because now your probability is 0.3522. It was fairly unlikely to get all 5, but to get 2 is over a third likelihood. Okay, so that's some of the calculations involved in hypergeometric and binomial. If you have any questions, let me know.